Started. I already click
No,
on.
sir. No, sir. It hasn't started, sir.
Yes, it is started.
Yes, sir, it
Yes,
is
sir.
okay now.
Now started.
Okay. So what I was saying that as an engineer, we can take the decisions. Now we know that due to huge populations and or the growing of the populations in the world, whatever the facilities and whatever the resources are available in the earth surface or in the subsurface layers, we are extracting the resources, we are utilizing that, and as a byproduct we are releasing them into the environment. For a given example, when we are cutting the trees, we are burning it. Ultimately the carbon monoxide, carbon dioxide used to be, and carbon monoxide used to be formed, and it is coming to the atmosphere. You know, during the when the civilizations has been started, countries they started taking out result and they started burning it. Normally the carbon dioxide concentration used to be in the atmosphere, it is to be 200 to 300 ppmb level. Ppmb means parts per million by volume. Within 50 years it is observed that the concentration become double in the atmosphere, in the ambient air. Now suppose something you are burning. When you are burning, so whatever is the gases or the fume is coming out, whatever you are burning, so uh, at that the concentration will be high. Okay, but in the surrounding atmosphere where you are sitting, there will be the normal concentration. But when it is going to mix in the air, the concentration of the air is going to increase. And now that is done repeatedly year by year, and if and that burning rate is very high, what will happen? The concentration will be increased, and by that way concentration is increased of carbon dioxide very high level. So problem being started, whatever I can remember, I think I can say-
Sir.
Sir, you're muted.
Muted, sir. You're muted.
एक्चुअली सर खुद से म्यूटेड हुआ है, सर ही प्रेजेंटर है अकेला ही।
Yes.
गलती से दबा दिया शायद. Sir.
Sorry students for interruptions. uh, okay, so by that way the undesirable gases concentration in the atmosphere used to be increases. Result is that whatever the concentration should be presence in the air and which is good for our uh, human health, that is not sustained, and that is creating problem for the human. Okay, what I was trying to say, I think I forget the exact year. I think 1860 or 1870 like that. Uh, in German, there is to be maple forest. Okay, so suddenly rainfall occurs as usual.
Hello, sir. Sorry to interrupt that.
Bolo.
Sir, sir,
Bolo.
are you sharing your screen?
No, no, no. I did not share. I just allowing to listen the things.
Okay,
Okay.
sir. Thank you.
So at the time that rainfall occurs, okay, and the people observe that there was one forest, okay, that forest is called black forest. That black forest is vanished. Vanished means all the trees has been died. So the scientists, the people were surprised why it is happened, and when the scientists work on it, and they found that acid rain is occurs. So first time the words came in the picture, acid rain. What is acid rain? That means in the normal pH, what's happened that some amount of or little amount of carbon dioxide used to be dissolved in the water, and when rain needs to be come down, it's become carbonic acid, and the pH value of the rainwater is to be little less than 7 actually. Now that pH value of that rainwater was near about 2 to 3, so it's a highly acidic in nature. So why it is so? And after that they found that uh, this is because of the sulfur oxides and the nitrogen oxides which are present in the atmosphere. They uh, dissolve in the water and they form acids, and these are the strong acid we know, and they destroyed the chlorophyll of the trees, and also they destroyed the roots of the trees. Result is that almost 50% forest has been dead. And after that, when they realize that okay, from the air pollution these types of problems are happening not only to the human, to the environment, then rules and regulations has started come. Now today we'll start discussions about the atmosphere, because we know that we are living in the above the surface, and whatever the oxygen is required we are taking from the air. Can you tell me that whatever the oxygen concentration that is mm, uh, means it's increase or it is decreasing order, or it is remain constant? Suppose if you look back at around the 50 to uh, 500 million years or 1 billion years. Students, some sound is coming. Sachin, can you tell me that oxygen concentration is increasing or decreasing? If
Increasing, I
You said
think.
decreasing.
yes, it is.
Decreasing.
No, it is increasing. If you look back at the 1 billion year ago or more than that, at the time oxygen concentration was very less. It is increases with the time due to the photosynthesis. So how the Earth has been formed? If you look back around 4.5 billion years ago, that Earth was formed from the sun. Several hypotheses is there. I'm not going on that in detail. So first, in the Earth, in the first stage, Earth is a molten mass. When it is cooled down, so one thin earth crust is to be formed. At the time, volcanic eruptions was more rapid. S- Gradually, it's cooled down, and some amount of water is come from the rock minerals, which is called connate water actually, due to the volcanic eruptions. So gradually oceans are formed. When the oceans are formed in the shallow water, in the presence of uh, uh, the minerals which are essential for the life. First cell was from approximately 2.5 billion ago. These are all the hypotheses. Okay, and when first life was formed, then gradually the life increases in the ocean water. So by that way, it's took more than billions of years, and after that, approximately I think 1.5 billion years ago, that photosynthesis bacteria come in the picture, and they started formation of the oxygen. When that oxygen was started forming, result is that whatever the oxygen they used to be formed, they used to be initially dissolved in the water. Gradually, the concentration increases, come into the atmosphere. When it is come into the atmosphere, the more life or variety of species come in the picture. So by that way, that oxygen concentration increases and the variety of species is to increases. Approximately, whatever the observations, 500 million years ago, that uh, that plants come into the picture, and when the plants come into the picture, so the growth of the that formation of the oxygen is becoming more. When the formation of the oxygen is becoming more, then it is very easy for the sustain of the life. So life started living in the land. Earlier, the life used to be live in the ocean's water only. And due to the photosynthesis, that oxygen concentration increases. When that oxygen concentration increases, it reaches to the stratosphere, and it's from ozone layer. When the uh, ozone layer used to be formed, then UV protection used to be there, then it is more easy for the sustaining of the life in the earth surface. So growth used to be there, but nowadays we are destroying that. Okay, so now I'm coming to the presentation. I'm sharing my screen. So today we'll start the earth atmosphere. Okay, I'm writing my mobile number here. If you require, you should have it, my mobile number. So what is the earth atmosphere basically?
साफ
This is,
मतलब
yes,
ब्लैंक हो गया, पहले दिख रहा था ब्लैंक हो गया सर.
blank हो गया, एक मिनट.
नहीं सर, नहीं ब्लैंक हुआ सर.
No, sir, it is visible.
No, sir, it's clear.
Okay, I think there will be some network issues in your system. It is visible to all of you.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir, it is
Now,
visible, sir.
Yes, sir.
Earth atmosphere is a layer of gases surrounding the planet. Earth is surrounded by a blanket of air, which we call the atmosphere. It reaches over 900 kilometers from the surface of the Earth. So if we look at that, the gases which are present in the atmosphere, normally dominating gas is the nitrogen, then
Yes, sir.
oxygen, then helium. The list of gases are there, I'm showing you. So these are present in the atmosphere. But if you go with the altitude, you can see that concentration of the gases is decreases. But these gases are present, that's why life is to be exist. Now, what is the role of the gases? First is the absorb the energy from the sun, especially the UV radiations, higher wavelengths. These are either absorbed or reflected. So only visible and IR portion, some amount of IR portion can able to reaches in the earth surface, which is good for the development of the biodiversity. Recycles water and other chemicals. This is very important because we know that we can drink only the potable water. Potable water means the water which have sufficient and minimum quantity of the uh, ions. Now, if you look at the ocean water, the ionic concentration is to be very high. Ionic concentration, that means salts. We can drink that water, and atmosphere is there. That's why weather phenomenon is there. So evaporation is to be takes place. When the evaporation is to be takes place, only water is to become. All the salts are used to be remain in the ocean's water, and that evaporated water again come down in the land surfaces, and its flowing is either form of the rainwater, or as a river, or in the form of groundwater in the subsurface layers, and this water is good for us. So that's why atmosphere recycles water and other chemicals, protects us from the high energy radiations and freezing vacuum of the space. What is the temperature of the space? It's very less. It's approximately 2 Kelvin. So at that high freezing temperature we can sustain, or in the vacuum we can sustain. So that's why atmosphere is required. The atmosphere protects and supports life. Obviously, by this way, atmosphere uh, supports us. So you can see here, this is the atmosphere compared to the Earth's surface. So just a thin veneer, 3/4 of the atmosphere by mass is in the lowest 33,000 feet, roughly 10 kilometers. So 3/4 mass is to be lies within the 10 kilometer. Total mass of the atmosphere is 5.10 into, this is the just value, 5.3 into 10 to the power 21 grams. Of this total mass, 99.9% lies below 80 kilometer level. You can see atmosphere exists up to 900 kilometer, but maximum portions or maximum mass presence within the 80 kilometer only. That means up to the mesosphere only. So now many things are present in the atmosphere. First, the most important compositions, that is the gases. So only the gases is present in the atmosphere? No, some other things are also present in the atmosphere. That is the water vapor, which is the most important thing. Third is the suspended particulate matters. So these things I'm categorically saying. So these three things are present in the atmosphere. So, and this is only one gases. No, this is the mixture of gases. Roughly, we say that the nitrogen concentration is the 78% and oxygen concentration 21%. So you can see that is already 99% is over. So by the other gases, this 1% is to be filled up. Now, Earth's atmosphere made of a mixture of the gases called air. Nitrogen gas makes up to about 78% of the Earth's atmosphere. Second most abundant gas is oxygen, which is makes up to 21% of the Earth's atmosphere. Third is the argon, 0.9. So 99.9% is over. Next is the carbon dioxide, CO2, that is 0.03 percentage. आप बोलोगे सर कार्बन डाइऑक्साइड concentration तो बहुत कम है. It's a very less. Why you are worried about that? Yes, we are worried about that because in that lowest concentration we can sustain. If the concentration is increased, then it will be very difficult for us. The amount of the water vapor varies from 1% to 4%. That is basically depend on the geographical and geological locations, and also the weather, that how much water vapor will be present in the atmosphere. If you go in the normal days in the coastal areas, you can see that the water vapor concentration is to be very high. But in the semi-arid region, you go that water vapor concentration is to be quite low. Again, it's changed to season to season in a particular locations. So water vapor concentration is to be varies. But water vapor presence only in the stratosphere. Okay, not in the other spheres. Now this is the list. You can see nitrogen, oxygen, argon, carbon dioxide, neon, helium, krypton, sulfur dioxide, methane, hydrogen, uh, nitrous oxide, xenon, ozone, nitrogen dioxide, iodine, carbon monoxide, ammonia. So these are the stress quantity. Okay, give me write something. So among of them, that when the concentration of these gases is to be increased, in the especially in the stratosphere, the sulfur oxide, nitrogen oxide, ozone. Ozone is good when it is present in the stratosphere, but it is present in the troposphere. It's a very dangerous. Carbon monoxide. Carbon monoxide concentration in the atmosphere is to be very less, because carbon monoxide is to react with the oxygen, it's converted to the carbon dioxide, but it's a very carcinogenic in nature. If the concentration is increased more than the 10 ppmb level, then the people may die. So so normally we unit that this is the unit we normally use, ppmb, parts per million by volume. Just a minute. Now only the gases and water? No, some non-gaseous constitutions also present. Hydrometers, these are the rain clouds or hails. particulates or and aerosols. Aerosols is very important. Aerosols are there is there. That's why that clouds formation used to be there, and the freezing or condensation used to be occurs. Otherwise, rains will not occur. Aerosols. Aerosols is liquid or solid dispersion in gases, usually air. Particulate can be inorganic, organic. That is the soil, smoke, soot from fire, dirt, sea salt, ash, and dust from the volcanic eruptions and aerosols. Inorganic seeds, spores, and the pollens, bacteria, and all the things. Nowadays, we are really worried about the particulate matter, especially whatever we are released into the atmosphere. Basically, the coal burning factories or the thermal power plant, they are releasing flies into the atmosphere, and the concentration level, the diameter of that suspended particulate matter is to be very, very less. Sometimes it is less than 1 micrometer that can easily sustain in the atmosphere for a longer period of time. And when you take the breath, it's directly lodged into our lungs. Result is that there is a highly chance of develop of the asthma disease or other lungs diseases. So why particulate matters are important? Act as a condensation and the freezing nuclei. As I told you, water like to condense or freeze onto the particle, can absorb or scatter radiations, reduce visibility, can scatter solar radiations to space. That's why planet is cool. Can impact on the human health. Whatever I was saying, can irritate lungs, initiate asthma and heart diseases. Now, based on the compositions of the gases, atmosphere classified into two groups. One is the homosphere and the atmosphere, heterosphere. What does it mean, compositions? If you look at the ratio of the hydrogen, oxygen, not hydrogen, nitrogen, oxygen, and carbon dioxide and other gases, if you look at the ratio of these gases, that's are used to be almost constant up to the 80 kilometer. Okay. So that's why it is called homosphere. Above 80 kilometer, what's happened? Whatever the gases are there, they are present in the based on their atomic weight. Okay, that's why that above 80 kilometer it is called heterosphere. So this layer, four spherical layers. So the lowest layer is dominated by the molecular nitrogen. Okay, next layer is the atomic oxygen. Try to keep in remember atomic oxygen. First one is the molecular nitrogen, next is the atomic oxygen. Third one is dominated by the helium atom, and finally, and at the above layer, that is the hydrogen atoms. Now, changes of the pressure. We know we are already we have that information that pressure is to be changes with the altitude, or density of the gases is to be decreases with the altitude. So atmospheric pressure is the force per unit area extracted into the surface by the weight of the air above that surface in the atmosphere of the earth. The gas molecules close to earth's surface are packed together very closely. This means pressure is lower at the higher up, and you go into the atmosphere. So pressure is to be increases. How the pressure? This is the graph. So at the nearby the surface, the pressure is to be approximately 1 bar or thousands millibar. If you go with the altitude, you can see that above when the it reaches at approximately 36 kilometer, the its pressure is very, very decreases. So one half of the atmospheric lies below uh, an altitude of 5.6 kilometers. So here will be the 5.6. You can see almost 50% is coming or 60% is coming as per the graph. Above 100 kilometer, only 0.403% of all the gases making up the atmosphere remains. So density is and the pressure is rapidly decreases with the altitudes. So this is the structure of the atmosphere. Uh, uh, this is if you go from the beneath, so that is the lower one is the troposphere, next is the stratosphere, next is the mesosphere, and last one is the thermosphere. So troposphere exists from the uh, from the surface to the approximately 10 to 12 kilometer, and after that at the time temperature decreases with the altitude, again the temperature increases in case of stratosphere and reaches up to near about 0 degree centigrade temperature at the altitude of the 50 kilometer. Again temperature decreases and temperature reaches up to minus 110. This graph is little wrong. This reaches up to minus 110 degree centigrade temperature, and and in case of thermosphere, the temperature increases up to more than 1500 degree centigrade temperature. Toposphere, what is a toposphere? This is the lowest and the thinnest layer, 16 kilometer at the equator and 8 kilometer at the poles. Average is 12 kilometer. It is like that. I'm drawing it here. My drawing is not good, so please don't mind it. And this is not to the scale. So in the polar region, the it is most thinner. This is 8 kilometer, and here you can see in the equator region that is 16 kilometer. So on average, we are considering as a 12 kilometer. Okay. So in this troposphere, 90% of the atmospheric mass is to be present. Temperature decreases with the altitude at the rate of 6.5 degrees centigrade per kilometer. So please keep in mind on this word. The temperature decreases with the altitude 6.5 degrees centigrade per kilometer. That is called environmental relapse rate. This is a normal phenomenon. If we go with the altitude, so temperature decrease rate is 6.5 degrees centigrade per kilometer. You might be thinking that, sir, ये तो हमेशा क्या यही value रहता है? No, it's not like that. Actually, in the daytime, when the surface is to be much more hotter, so temperature variations used to be there nearby the surface up to few 100 meters or 200 meters or 300 meters like that, and after that the decrease rate used to be constant. Okay, and this is totally based on that weather, that how the weather phenomenon will be the nearby the surface. That is actually nearby the surface I'm talking about. Otherwise the temperature decrease rate is the 6.5 degrees centigrade per kilometer. Okay, that's why when we reach the 12 kilometer altitude, the temperature is approximately minus 30 degrees centigrade temperature. When we reaches about 12 kilometer, the temperature is up to minus 50 to minus 60 degrees centigrade temperature. This layer is characterized by the strong vertical mixing, overshooting, turbulence, and weather phenomenon. So whatever the weather phenomenon is there, that's occurs only this sphere, not other sphere. So that's why this sphere is called weather sphere. Please remember that this sphere is called weather sphere. Boundary between the troposphere and the stratosphere is called tropopause. Okay. So that pauses approximately 5 kilometer. In the pauses, the temperature variations used to be almost nil, or this is a constant. Suppose this is the graph. So you can see here the temperature gradient is changing. So this is called pause. Okay, the width approximately 5 kilometer. In every pauses, the width approximately 5 kilometer. Okay. So, and the pause name is given from the lower sphere name. So lower sphere name is the troposphere. That's why that that pause's name is the tropopause. So above that is called stratopause. Above that, mesopause. Stratosphere. It exists 12 to 15 kilometers above the surface. Temperature increases with the altitude. Can you tell why the temperature increases in that sphere? Because
Sir,
of the
clouds there. Clouds is not there. Solar radiation is coming.
No. It is not like that. सोलर रेडिएशन जब तक कहीं पे नहीं गिरता है ना, तब तक टेम्परेचर इंक्रीज नहीं होता है. उसको कोई कैप्चर करने वाला चाहिए, है ना. आप ऐसे हाथ रखोगे, आप मतलब एयर को टच करोगे तो आपको मतलब टेम्परेचर नहीं मिलेगा, क्योंकि एयर में कोई पार्टिकल्स या कुछ भी रहना चाहिए जो टेम्परेचर को इंक्रीज कर सकता है. दैट्स व्हाई when the suspended particulate matters are used to be present in the atmosphere, they absorb some amounts of radiation and they reflected back to the atmosphere. Temperature is used to be increased. Okay, and some gases are there who are able to capture the radiations. They can help to heat it up, just like ozone gas. Ozone gas normally presents in the 20 to 40 kilometer altitude. Now ozone have the capability, in the next class I will discuss, now not much more time is there, 20 to 40 kilometer. So these have capability to absorb the radiations or the UV radiations, especially UVB radiations. So they are capturing the radiations, they heat it up, they breaking down and they releasing the heat. Okay, so by that way temperature is to be increased. Almost no weather occurs stable, not at all of vertical mixing. Normally no vertical mixing is there. That's why it is called stable. Dry because no uh, water vapor. Yes, no water molecules are present. Only occasionally get overshooting top from the convection forcing into the layer. When we will discuss about the uh, destroying of the hole or ozone hole formation, at that time I will discuss about that. Contains high level of ozone. Upper boundary is called stratosphere. Now coming to the mesosphere. Now in case of stratosphere, the ozone layer is there, that's the temperature increases. But in the mesosphere, which is extend up to 80 kilometer, no gases constituents are there who can absorb the radiations. So temperature rapidly decreases and it reaches up to minus 110 degrees centigrade temperature. Gases are less dense, temperature decreases as the altitude increase. Gases in these layers absorb very little UV radiations. Upper boundary is called mesopause. Now I am coming to the thermosphere. So fourth sphere is there. Above the mesosphere and extended almost 600 kilometer high. Okay, that is called thermosphere. Thermosphere increases with the altitude, readily absorbs solar radiations. Temperature can go as high as 1500 degrees centigrade temperature, reflects radio waves. So that is sometimes, that's why it is called ionosphere also. Now I think you can remember when we are discussing about the classification of the atmosphere based on the compositions, that is called Ionosphere and Heterosphere. So mainly dominating is in this thermosphere, that is the heterosphere. If you look at that structure of the sphere, you can see that atomic oxygens are there and hydrogen atoms are there. These are the who have the capability or capacity to absorb the solar radiations, and temperature used to be increased. That these gases are used to be ionized. So that's why ionosphere is to be formed. Okay. Now ionosphere, an electrically charged layer located at the altitude range from between 60 to 600 kilometers. Now why it is 60 to 600 kilometers? Because above the 60 kilometer, when it is almost the mesosphere is over or mesosphere begins to start it, if you look at the ratio of the gases after 80 kilometer, so only nitrogen and some amount of oxygen is to be present. So at that altitude, the gases is to be in the presence of sunlight, they is to be charged. So molecule of nitrogens and antioxidants are readily ionized by absorb high energy short wave solar radiations. That ionosphere can reflect the radio waves on the basis of ionic density. The atmosphere is subdivided into three layers: D dynamo layer 60 to 90 kilometer, E layer uh, heaviside and canally layer, that is 90 to 150 kilometer, F layer above 150 kilometer. I am not going much more discussions about the ionosphere because this is not our scope, what is exactly going on. But our main motto is to understand the things which are present in the ionosphere, so that whatever the pollutants we are generating, how they are harming them. Okay. The concentration of the charged particles change from the day to night in the D and E layers. These layers are weak and dissipate at night because the gases, especially nitrogen and oxygen, they are is to be charged in the presence of X-rays and the UV rays. Okay, so uh, in the night time, no radiations is to be there. That's why they are disappears. The repairing during and repaired during the day, the F layer is present both day and night because that is dominated mainly by the hydrogen atoms. So communications of the on the earth on depend on the satellite. Satellite transmit information used through the television source, radio broadcasts data, and the photos used in the weather reports and long distance telephone calls. Okay. to this is, I'm not continuing, I'm leaving you. So Aurora, one of the nature's most interesting spectacle take a place in the ionosphere. The Aurora Borealis, I think lots of YouTube videos is there. हाँ बोलो. Hello.
You may continue, sir, please.
Yes, sir.
Who is that guy? The Aurora Borealis in the northern hemisphere, actually whatever we can see from the northern hemisphere, that is name is given Aurora Borealis, and Aurora Australis in case of southern hemisphere. Lots of YouTube videos are there. You just go through it if you not yet seen. I think many of us seen you in the Discovery channels and other YouTube channels. Go through it and you can see it. It's a very beautiful. The occurrence of the auroral display is correlated in the time with the solar flare activity and the geographic locations with the Earth's magnetic pole. Now coming to the exosphere, this layer is a very important layer. This layer lies behind the ionosphere. So when the ionosphere is over above 500 kilometer, so the density of the gases is to be very less. So this is so much less that this is so much less that air molecule moving directly outwards has a 50% chance of escaping rather than the colliding with another molecule. So that's why, and we know that in the top of the layers normally that hydrogen is to be present. So hydrogen is escaping from the atmosphere. Some nowadays recently it is being discovered that we are also losing the oxygen atoms from the exosphere. So this is the satellite exists above the exosphere or in the exosphere, and this is the thermosphere. Now above that only one layer is remains, that is the magnetosphere. This is the A Van Allen radiation belt is a zone of energetic charged particles. It includes two belts. The two belts consist of meson, photon, positron, and energetic electrons and alpha particles. And now in case of the two belts are there, that is the inner belt radiations, and another one is the outer belt radiations. So in case of inner belt radiations, the source of the particles is the surface of the earth, or the earth, not surface of the earth. And in case of outer belt, the whatever the particles are present, these are source of the particles is the sun. So inner belt exists from the 2400 to 5600 kilometer, and outer belt exists from the 13,000 to 15,000 kilometer. Trapping the solar wind, the magnetic pole deflects those energetic particles and protects the atmosphere from the destructions. So these are the four spheres are there. Different layers are there in the atmosphere. Next class we have start the insolation, that how much radiations are coming from the sun, what is happening after that, and all the things. Okay, so I'm stopping the class here. Do you have any questions, students?
No, sir, it is okay.
Acha, now I think that you have the next class from the 11, no?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. एक minute.